So in this question here, we've got a double integral and x squared y is our integrand. And notice here we've got two with respect to, so dy and a dx. And we've got one region for both terms here for the upper bound and lower bound of omega. Now omega is drawn on this diagram here. So omega has been filled in and we've got two functions here. G of x, which is our ellipse, which gives an equation of x squared plus 3y squared equals 20. And we've got a straight line here, f of x, which is just mx plus c. We need to find that from our equation for our ellipse. And we've defined the term for omega here. So it's the bound, included the red lines here as well. So it's a closed region as well. Now, how do we find mx plus c from this ellipse equation? Well, let's just write our functions up here. So g of x equals x squared plus 3y squared equals 20. So x squared plus 3y squared equals 20. Okay, now what we've got here, 2 points which intersect the y-axis and the x-axis, both at the positive parts of the quadrant. So what happens when y equals 0 for an ellipse? Well, this one here will give us x equals root 20 and 0. So that'd be the point there. So from that you can see there that the original radius before it's been squashed into an ellipse is square root of 20, just like in a circle. Now this point here, that's going to be x is 0, but the y point will be the root 20 divided by square root of 3. So root 20 root 3. So that's our coordinates of the two parts. Now to find our mx plus c, now we've got 2 points on a straight line, we can do that. So we've got y equals mx plus c. So our m is change in y over change in x. So let's work that out. So change in y, starting from here. So it goes from root 20 over root 3 to this point here, which is 0. So root 20 over root 3 minus 0 is just root 20 over root 3. And then our change in x going from here to here, so it's 0 minus root 20. So I'll just write there minus root 20. That will give us our m. Well, if we simplify that off, the root 20s will cancel out, the root 3 will go in the denominator. Obviously we've got a minus sign there, so we've got minus 1 over root 3. So that's our m value. So plug that into our equation and let's see what we've got. So y equals minus x over root 3 plus c. Now if x equals 0, y is root 20 over root 3. So we've got root 20 over root 3 equals minus 0 over root 3 plus c. Obviously that counts to nothing, so therefore c is the same as this side. So our function there, f of x, that's going to give me y equals minus x over root 3 plus root 20 over root 3. So that sets us up for our bounds of integration. So let's set that up now. Okay, now for our dx, we want our change in x. So x just goes from 0 to root 20. So we write here x equals 0 and x equals root 20. So we see clearly that's for our x values. Now the next one, we want our, because we're normalising with regards to the x-axis, that's why we put the dx in the right hand side of these two. So as we're normalising with regards to the x-axis, now what we've got is we've got this one for our lower bound, which is this one here. So our function there is minus x over root 3 plus the root 20 over 3. So that would be y equals minus x over root 3 plus root 20 over root 3. So that takes care of that. But now to normalise in terms of the x-axis for the upper bound, we need to make y the subject of this one here. So let's just do that on the side here. So I've got it written down here. So we get 3y squared equals 20 minus x squared. And then let's get this y on its own. So we've got y squared equals 20 over 3 minus x squared over 3. So y equals plus or minus square root 20 over 3 minus x squared over 3. So we've got two values there. That makes it a bit awkward for our integration. But let's have a look at our diagram. We've got x is only ever positive, y is only ever positive. So the negative version we don't need. So we can take that one out. So now we can write our upper bound as this radical here, y equals square root of 20 over 3 minus x squared over 3. Now they're awkward looking bounds of integration, but as our integrand here is x squared y, I'm sure we can handle it just fine. So x squared y and then dy dx. So this is our setup in regards to normalising with the x-axis. Now what you can do, you can switch the parameters round and do dx dy, but then you'll have to normalise the equations with regards to the y-axis. You will still get to the same answer. I'll leave that to you to have a go at. So integrating inside here now with respect to y, because dy is on the inner, that's what we need to do first. So y with regards to y will become y squared over 2. X squared will just stay as it's a constant. So now let's do that. So now we've got x equals 0, x equals root 20. That's that one there. Now we're going to integrate this straight off. So x squared, y squared over 2. So that's going to give us, let's just open a bracket, x squared, y squared all over 2. So I'll just write a half there. And then our values for y, which we need to plug in here, are these ones here. So y equals this and y equals that. So y equals minus x over root 3 plus root 20 over root 3. And here we've got square root of 20 over 3 minus x squared over 3. Okay, so now whenever we see a y, we plug in our value here. So let's go for that. Let's simplify, not forgetting to put our dx at the end. So x equals root 20. We've still got this integral to do, so that still stays in there. Now let's calculate this one. A half is a multiple, and so is the x squared in terms of this question here. So I'll bring the half out to the front, and I've got to leave the x squared obviously inside. So now let's calculate our upper and lower bound. Well, we've got y squared. So what happens when we square this? Well, we just lose the radical. So that's pretty straightforward. So 20 over 3 minus x squared over 3. And then let's subtract this one, which is y squared. So we can't just square each individual term, we've got to square the whole thing. So we've got minus x over root 3 plus root 20 over root 3, all squared, and then our dx. So that's our setup there. Okay, let's do another line. So now it's 1/2, x equals 0, x equals root 20. We can't miss that out, that has to stay. X squared. Right, now let's start working these out. So 20 over 3 minus x squared over 3. There's no signs here affecting anything, so you can just write them in as part of our answer. 20 over 3 minus x squared over 3. Now what we got here, let's go one step at a time. So if you square this first, we get x squared over 3, but then there's a minus sign here. So now I get minus x squared over 3. Look, we've got two of these, so we can just double that up. Then we've got to square this term. So if we square that, we just lose the radicals. So we get 20 over 3, but with a minus sign. So minus 20 over 3. That's worked pretty handy because these are now going to cancel out. But now let's go careful here because I'll have these two multiplied together twice. So now I'll have minus x root 20. So that's going to give me minus 2x root 20. And multiply root 3 with root 3, I'll just get 3. Okay, now just be careful here. I've got another minus sign here. So if I multiply those two together inside, I'll get a minus. But then I've got this minus here. So that's going to make that everything a plus. Okay, and then that's all with regards to x. Okay, so now what can we do here now? So obviously we went through this, that's cancelled. They become 2. And then we've got the 2x root 20 over 3. So let's put that all in there and multiply everybody by our x squared. So now we've got 1/2 x equals 0, x equals root 20. Let's distribute the x squared as we're going along here. So I've got minus 2x squared over 3, multiplied by the x squared. I've got minus 2x to the 4 over 3. So let's open up a new integrand, minus 2x to the 4 over 3. Now what have I got here? So I've got 2x root 20. Root 20 as a radical is 2 root 5. So I've got 4x root 5 over 3. So plus 4x root 5 over 3, and not forgetting to times by the x squared. So plus 4x cubed root 5 over 3. I've just left my radical on the outside there just to so we can see what's going on there. And that's all dx. Okay, right. Now let's bring this up to the top and let's see if we can get this and integrate with these as our bounds. Okay, so it's all up here now, and I've just simplified this off a little bit, put the 4 root 5 x cubed over 3 and then the minus sign second. So instead of having this one first, I'll put that second, just easier for me to work with. So now what can we do here now? Well, to integrate with regards to x, we can go through this, but what I'm going to do is I'm going to take this 3 out and divide by 3. So that's going to give me 1/3 if I cancel those. And then here I've got 2, that's common, so I can then times by 2 as well. So that's then going to give me 2 over 6, which is 1/3. So 1/3, then x equals 0, x equals root 20, and then simplified off, I've got 2 root 5 x cubed. So that's a bit more easier to work with, and minus, I've got taken the 2 out of that, so I've got minus x to the 4. And that's all in my integrand, and that's dx. So now we can integrate straight away with this. We've got 2 terms here, which is pretty straightforward with the power rule. So x to the 4 over 4. So x to the 4 over 4. And I've got 2 root 5 multiplied that by that. So I just open this up and bring the 2 root 5 out. Okay, now this 1/3 I need to keep. So 1/3 comes out here. So that's the first part integrated. That's taken care of. X to the 4 gives us x to the 5 over 5. So minus x to the 5 over 5. And now I've got my parameters of integration, which are x equals 0 and root 20. So I'm just going to now write 0 and root 20 as we've integrated, and there's only x in there. So where I see an x, substitute root 20. So let's go for that. So 1/3 multiplied by 2 root 5, let's keep that, over 4. So actually I can divide these ones here, so I can just now have root 5 over 2. And what's my x to the power of 4? Well, if x is root 20, square that, I'll get 20. Square again to get x to the 4, I'll get 400. So I've got root 5 times 400. So that's the first part taken care of. Let's just simplify while we're at it. So that cancels out and that becomes 200. So I've got 200 root 5. And then I've got minus x to the power of 5 divided by 5. Well, x to the power of 4 is 200. Sorry, x to the power of 4 is 400. And times by another root 20, I'm going to have 400 root 20. And then that's all going to be divided by 5. Okay, so that takes care of that. I've still got my third. And if I plug in 0 here, I'll end up with nothing. So I can just write here minus nothing just as a note. But that's not going to affect our answer. We can just concentrate on this now. So 400 over 5 I can simplify straight away. That's going to give me 1. That's going to give me 80. So now I've got 80 root 2 in there. So now let's bring the 3 inside. So now I've got 200 root 5 over 3 minus, here I've got 80 root 20 over 3. Now root 20, if I get it both in terms of root 5, that's going to help me a lot. So root 20 is 2 root 5, so that's going to give me 160 root 5 divided by 3. Okay, and that's a straightforward subtraction. I'm now going to be left with 200 minus 160 is 40. So it's 40 root 5 over 3. That's my exact answer for my integral. Now, if I plug that into a calculator, I'll get an approximate value, as root 5 is irrational. So I'll get approximately 29.81. And that is my answer. And that's our double integration taken care of. Okay.